When you click Buy on an app, you expect everything to happen right now. The payment clears, the inventory drops by one, and your tracking interface updates the moment the delivery driver turns the corner. We are used to this rapid-fire chain reaction. You swipe a card, the bank approves the charge, the warehouse reserves your item, and the confirmation email hits your inbox before you've even closed the browser tab. But behind the scenes of large-scale digital operations, the data often isn't moving instantly at all. Millions of those transactions may actually sit quietly in a queue, waiting until midnight to be processed in a single group. This creates the core tension that drives modern data engineering. Companies want the speed of instant reactions, but moving every single piece of data the millisecond it's created requires constant, high-capacity infrastructure. Choosing between these two speeds is a central challenge for engineering teams, as a decision to process everything in real time can quickly lead to cloud bills that far exceed the company's expectations. To solve this, engineers divide the work into two different approaches. First is batch processing. It is methodical. You collect data over a set period of time, maybe a day, maybe a week, and then process those records together as one coordinated group. Then there is real-time processing. This is an always-on pipeline. The system listens continuously and processes the incoming data the exact millisecond an event is generated. This split-screen comparison shows the core divide. On the left is the expectation, handling single events the moment they happen. On the right is the reality for most systems, organizing heavy volumes of data into grouped batches. You choose between the now or the group. Making this choice dictates the entire architecture you build, the specialized tools you buy, and the size of the server bills you pay at the end of the month. Get this wrong and you end up in one of two traps. You either cripple your user experience by making people wait hours for something they need immediately, or you build a highly complex infrastructure to process data that nobody actually needed until tomorrow anyway. This quadrant chart maps out how to weigh these options. The vertical axis shows your need for immediate action, and the horizontal axis tracks infrastructure complexity. Down in the bottom left, we have a point for payroll, or nightly ETL pipelines. This is classic batch processing. The system waits for off-peak hours to run transformation jobs. Because it runs on a fixed schedule, compute costs stay predictable. You can crunch millions of historical records simultaneously without worrying about traffic spikes crashing the pipeline.
But that predictability comes at the cost of high latency. A business leader cannot make a midday pivot based on yesterday's data. Now, contrast that with the top right. To catch fraud, the system maintains an always-on streaming architecture, capturing single events instantly. The result is ultra-low latency. The bank doesn't wait to see if the purchase was bad. It uses that instant data stream to automatically intervene and block the stolen card before the thief leaves the store. Maintaining that continuous awareness requires heavy compute resources running 24/7. It also demands specialized engineering to keep the pipeline fault-tolerant, resulting in a substantial increase in overhead compared to scheduled jobs. Continuous streaming guarantees speed, but it forces a higher price for maintenance. True real-time data is a premium luxury, and it should only be purchased when immediate action is the core value of the product itself. Inside a large enterprise, you rarely see a company pick just one side of that quadrant. They use both methods simultaneously to build a hybrid architecture. Think about a live order on a major e-commerce site. When you insert your card, the transaction demands instant verification and the immediate reservation of the physical item in the warehouse. To prevent friction for the buyer, this entire front-end customer interaction runs entirely on a real-time, low-latency streaming stack. The data moves continuously, so the customer never sees a loading screen. But that same company has an accounting team that needs to see the total global sales numbers at the end of the day. That back-end reporting uses a batch processing stack. Instead of calculating the global revenue after every individual purchase, it grabs all 1 million orders at midnight and processes them together, which conserves heavy compute resources. To make this work, the engineering team has to build and maintain two separate technology stacks. They need tools like Apache Kafka for the live front-end streams, and tools like Apache Spark or AWS Glue for heavy, scheduled back-end jobs. Delivering instant customer gratification on the front end and back end efficiency requires a company to double its system complexity and hire engineers who understand both environments.
This flowchart is an architecture evaluator designed to prevent teams from over-engineering their pipelines just to chase industry trends. It starts with one strict question: does this data trigger an immediate physical or financial intervention? If the answer is yes, like blocking a fraudulent charge or updating a driver's live GPS location, then you have a definitive use case. You need a real-time streaming stack. But if the answer is no, you move to the second question. Is analyzing historical context more important than knowing the exact current status? If your primary goal is looking at historical trends, calculating payroll, or generating daily sales figures, you protect your operational budget. You default strictly to a batch stack. If the arrival of the data doesn't require a system to automatically and immediately react, you do not have a real-time problem. For an aspiring data engineer, looking at the sheer volume of streaming platforms and batch tools on the market can be incredibly overwhelming. The clearest path forward is to dedicate all of your initial study hours strictly to mastering batch processing and foundational ETL pipelines. The return on investment for this focus is foundational. By understanding how to extract, transform, and load historical data on a schedule, you prepare yourself for the daily workload that makes up roughly 80